Thanks everyone. I'm going to talk today about understanding IMIs and I guess the implications that they have for us, particularly in the north with our summer winter crop rotations. Probably more for us at BASF, so we initially developed a lot of those IMI herbicides, and the Clearfield trait actually belongs to BASF. So we as a company have a responsibility around stewardship to the industry and stewardship of that chemistry. So stewardship, basically the job of supervising or taking care of something. I think we all have a responsibility to make sure that we have these herbicides or this chemistry in the system for as long as possible.
Oh. Is that yes?
Basically making sure we're minimising damage to sensitive crops, minimising drift, but also making sure that we are minimising, crop rotation options. If we're using some of these, especially Metabolic or flame products, we're using them and locking ourselves out. So that in itself is a stewardship issue. This is, the slides have all jumped around, but there's a website, the International Survey of Resistant Weeds. It's a really interesting one. You'll see that we're in the silver medal position there. It's not one that we necessarily want to be in. So those across the top, you'll see the modes of action. That's according to HRAC. So group A's are our group A's. The B's are our B's. C's is the same as ours. Their group D is our group L. Their group G is our group M, glyphosate. K1 is D. So looking across there, you can see that our A's and B's are, like most countries, I guess, they're the most resistant, whether we've got the most resistant cases. And just out of curiosity, that numbering or lettering system for the herbicide modes of action, I don't know if people are aware, but the lettering, so group A through to whatever it might be, Z, they were actually listed that way because that was the likelihood of that group developing resistance. So group A's were the most likely. I think it's pretty telling that we've got glyphosate in Australia that's a group M herbicide. We have huge resistance issues. So that's down to how we use those products. So we've used them in such a way that we have selectively chosen to overuse them, and that's why we have the increase in resistance. Group B is still a really handy tool, but obviously by nature they're more prone to resistance. So we really need to look at how we are using these products and where we're using them. Clearfield Technology. So the first Clearfield Technology was developed and launched into Australia in the early 2000s. That was Clearfield canola down south. Since then, we've seen a whole host of crops come through, either with Clearfield tolerance. So we've got sunnies, sorghum, maize, wheat, barley, canola. We've also got lentils that are inherently, tolerant to IMI herbicides. So as part of the Group B mode of action, that's where the IMIs fit. So you'll see up here, we've got SUs. The IMIs are over here. There's 6 actives in the IMI group. Only 4 of those actives are actually registered for use in Australia. So I just wanted to talk through those actives to give you the information to make better decisions about where those products will or won't fit in your system and make the best decision about, where to put those into your system. So there won't be a test at the end of this. That slide there, that is basically all of the metabolic pathways inside of a plant cell. So anything that you'll see, there's some little yellow highlighted bits, those are amino acids. So 20 amino acids essential that are produced in this plant. So we've got the mitochondria here. Out of interest, so glyphosate works up here. That's where it works in the shikimate pathways. Group A's work in that section there. Group B's are in that same area, but just outside the mitochondria. So you can see how complex this stuff is. You don't have to remember any of this. What I wanted to show you is basically we've got pyruvate that's going through to create 3 essential amino acids. Without those amino acids, the plant can't function. What Group B's do, they're ALS inhibitors, they block that. So you're getting 3 enzymes that cannot be produced. So the fact is that there will be a stockpile of those amino acids in the plant, and it will take a little while for the Group B's to work because the plant has to naturally deplete that stockpile before you will start to see plant symptoms and death. So what does it look like in the paddock when you've sprayed it? As I said, blocks 3 amino acids. It's not really, doesn't matter which ones they are. You don't have to remember that. But basically the cell function will continue for a little while. It's got that, it's got a bit of a stock of reserves there. So the plant function will continue for a while. The cells will slowly deplete those supplies. And you basically get, you see it at the root tips and the shoot tips. So you get root pruning and you'll just get, I suppose it'll look like it's just sit there. It'll look like a green skeleton sitting in the paddock. And it takes a fair while to die, so up to 3 weeks generally before you'll start to see plant death. It's a pretty slow and agonising process. So of those 4 IMIs that we talked about, basically they're very, very similar molecules. The only difference here is this side chain. So you've got a masoper, a masopic, a masothipper, and a masomox down the bottom. So yeah, if you're thinking of Intervix, a masomox and a masoper. If you're thinking of On Duty, another one of our herbicides, it's a masoper and a masopic. And if you're thinking Flame, for those of you that use Flame in residuals, a masopic. So basically when you're looking at IMI herbicides, you need to understand, I guess, their phys-chem properties. You need to understand what they're capable of to work out where to best use them. You don't have to remember any of this again. But yeah, so looking at this solubility. So when we're thinking about Intervix, we've got 2 products, pretty good solubility as far as solubility in water goes. A Flame type product, not very soluble at all. So one of my colleagues uses the analogy, this is about as soluble as sugar, it's about as soluble as gravel. And as far as soil breakdown, so knowing and understanding how it breaks down and under what conditions, that obviously tells you, is it useful as a residual, is it useful as a knockdown? It's a complex system. Those day ranges are the result, I guess, of various things. So it depends on microbes, depends on soil moisture, depends on soil pH, so many different things. But generally speaking, if you're looking, so, and I'll pick Flame. It used to be a product of ours. We no longer produce it. But you look at this. So this is half-life. So the time for half of the product in the soil to deplete. So 31 to 410 days. So those numbers on the right-hand side are probably more appropriate for a light sand. So think WA, low pH soil, not much microbial activity. So 410 days to 1 half-life. So that's about 1.25 years, roughly. So to plant a canola crop for a bloke in WA, you need 5 half-lives. So you're looking at up around 6 years to go back into a canola crop. So just think about the implications of where you're using these products. For us, we're quite lucky. When we're using Flame in our crops, we've got much lower half-lives. We don't plant canola, which is one of the most sensitive crops, but still we can get stuck. And I think, these last few summers, I guess we've really come unstuck in some places. One of the other things, log P. So all this number is, it's a log scale, so keep that in mind. Where it's a negative, it prefers to be in water, prefers water. Where it's a positive, it prefers oils, lipids, fats. So that will impact basically how that product is taken up in the plant, how it crosses membranes, whether it's better as a residual, whether it's better as a post-emergent application. So when you're looking at these, that's why we have Intervix. So these 2 products here, they're better as a foliar. They don't work very well as a residual. And when you're looking at Flame, on Duty is better, has a bit of residual activity, but also good as a foliar. And a masopic, much better as a residual. The other important thing, I guess, for us in the north particularly, when you look at foliar absorption, so how well or how much a plant takes up of any product is so reliant on so many different things: temperature, humidity, coverage, size of the weed itself, does it have hairy leaves, waxy leaves? With the IMIs, I guess one thing that we probably haven't been very conscious of, if you are using any IMI as a post-stem product, this is one example. So we did a masoper. So this is nutgrass, so it's a sedge. But looking at how much product did it take to get 90% control of the population. So at 21 degrees Celsius, 32 grams active, we got 90% control. Now think about this, particularly for anyone in the north. You bump the temperature up to 32 degrees, so that's a pretty, average to mild summer day up here, took 125 grams of active. So you think about using IMIs, whether you're using Intervix into a Clearfield crop in summer or in winter, think about your temperatures, because you need 4 times the product to get the same job as soon as you increase the temperature. So when you're looking at the rate ranges on the labels, I think for Intervix you'll see that winter is 300 to 750 mil. There's a reason that our summer range is 750 to 1 litre, because you just need that much more product to get the job done. Weed size, so the number of times you get a phone call and, you know, will it work on small fleabane? So send me a picture. Oh, it's knee high, it's got a few flowers, but it's small, like it's not as big as it could be. Any group B herbicide, doesn't matter what it is, can be, you know, Atlantis, Rexaid, any of these IMIs. It's really, really important that you target small weeds. By nature, it's an ALS inhibitor. That ALS enzyme is concentrated in new, young tissue. It is not concentrated in older tissue. So if you've got a big weed, a lot of old tissue, and you're trying to block this enzyme, the plant's going to shrug it off. So that's why it's really important. So yeah, basically by inhibiting that enzyme, you're going to get better control on the smaller weeds where you've got that increased ALS concentration. As far as the grasses go, the importance of weed size, so we don't recommend that last use pattern, that's off label, but if you're looking at Intervix, right, so 375 mil or the high rate of 750 mil, 1 to 3 leaf brome, you know, doing a pretty good job. You bump that up to 3 to 4 leaf, it's still holding in there, it's not too bad, but as soon as you go to early tillering, you can see that you're starting to lose control, absolutely, and that's just down to the fact that ALS inhibitors, group Bs, do not work on bigger grasses or bigger broadleaves. I guess this is the pertinent one. This is where most of the questions, to be honest, have come this summer particularly, but looking at plantbacks, particularly where people have been using flame. So how do we stop it from turning into a graveyard? There's a bloke who wrote an entire thesis on the soil plantback interaction of IMI herbicides. I haven't read it, I don't intend to read it. The fact is it's obviously very complicated. I can't explain it all to you, but I can give you a brief summary and hope that that helps us make better decisions. So when we look at the IMIs, basically each individual active binds differently. They all initially bind very strongly and fairly rapidly. Over time that bind becomes stronger. If you look at the graph over to the right, you'll see flame, it binds the strongest. So we've got a product there that has good residual, it's a really stable chemical, it's not very soluble, and it binds a lot, and it binds strongly. That's why it's a really good residual. That's also why we come unstuck when we don't have rainfall, because it's still just going to hang around. So yeah, Mazapic, most tightly bound. Intervix, obviously, less residual effect, less tightly bound. Now there's always, with any residual products, becomes the risk. So you put your product on, you're getting good control up here. You know, it's doing its job, it's controlling the weeds, everything's happy. At some point during the season, you will reach a critical point where the product is no longer killing the weeds that you're targeting, but you can't plant anything else because you're going to get damage in your crop. And that is, to us, you're getting poor weed control, but you're exposing those weeds to a sublethal dose of chemical. So that's a risk period for resistance right there, that red section. And beyond that is your safe zone, so you can plant, you know, choose crops to plant safely. So that's a best case scenario where you've got a relatively short risk zone in there. So for example, that's an Intervix, foliar product, small plantbacks. When you go into, for example, on duty used in Clearfield crops, or a Mazapic or flame used in fallow, you can see here it really blows out this risk zone. So when you're using them, keep your eyes on those paddocks. Anything that you're seeing come through, like Cowboy was saying, you know, take a chipping hoe, go out, keep your eyes on it, just because the flame's there, don't bank on it. And yeah, this period here, you may have to come back and do something else. That's where we're exposing, I guess, the bulk of our weeds to resistance right there. Now, Disclaimer, follow the label. There's Plantback recommendations on every label, rainfall requirement, sensitive crop information. Follow that as a rough guide. If you're stuck, if you get really stuck, there's options that you can still go back to. The introduction of Clearfield crops mean that you've got options to go back into flame country particularly. I guess the problem arises, and we've had the question time and time again, where people have been locked out. They've used flame in October, November. They're locked out, had a rainfall event, they want to plant something. What can I do? So they'll undoubtedly plant a Clearfield crop. The problem is that they then want to go back in and put an Intervix over the top. So we run into strife. We've just got 2 Group Bs in a row. So yes, you can absolutely go back into Clearfield tolerant varieties. They're the best option if you do have IMI residues in the paddock. But I would preface that with, as far as the chemical side of it goes, double check what you're doing. As far as the other options that you can go back into, chickies, field peas, mung beans, soys, they're pretty tolerant inherently. And you can see right down the bottom here, I guess cotton and canola are probably the watch outs. Cotton obviously more so for us, but they're the more sensitive ones. So yeah, but follow those labels. But if you do get stuck, there is options. But I would just say that be very careful, the increase in the number of Clearfield crops available, that's all good. But I think we need to use them very carefully and very wisely. Are we using them to get around our flame residues, or are we using them to manage our weeds? And make decisions with your herbicides according to that. So as far as the IMIs are concerned, the major, I suppose, form of breakdown is microbial. So as you all know, for microbial breakdown to happen, there has to be moisture. So wherever it is dry, you will not be having any microbial, very limited microbial activity. Soil moisture and time are the most important parts. pH plays a part, as does organic matter, and temperatures. So for us in the north, we probably don't see the same residuals that they would see down south because we've got warmer temperatures. And interestingly, so following on from some of the earlier presentations, what would the world look like without Group B chemistry? If you talk to the boys down south, research has shown that 4 applications will result in selection of resistant individuals. We heard that earlier. And we know, we've seen it, a population can go from a very small patch, 1 weed, and it can spread really quickly over a number of seasons. So Chris Preston did some work on looking at controlling brome grass. So how would you control brome grass if we had no Group Bs in our system? And he calculated, and I think Anthony talked about it earlier, you're looking at $75 a hectare for 85% control. So you're not even treading water, you're going backwards at that. So it just goes to show, we really do have to manage our chemistry very carefully. No more than 2 in any 4-year period. So if you've done a flame in fallow and done an Intervix over the top of an IMI tolerant crop, that's it, you're done. 4 years. Any use in a summer crop or in the fallow is the equivalent of a pre-emergent as far as the Group Bs go. So think about what you're going to do after that. And then if you're going into, doing a flame in fallow and then you put a wheat in, you want to throw an Atlantis over the top, 2 Group Bs again, so think about it. I guess for us in the north, we need to look at, which of our crops are the hardest to manage. Where do we really need, what's the weakest link in our system? Start there, and then work your way backwards. Choose your products really carefully. I think the last couple of years we've seen a lot of people get stuck in what I call the IMI cycle. They're planting an IMI tolerant crop to get around an IMI residue, but then they've got IMI residue, so they have to plant an IMI tolerant crop, and then it's just a vicious cycle. So I think we need to probably sit down and plan a little bit better as to how we are going to get out of this cycle. Use alternate mode of actions. Pre-emergent herbicides, I think, we probably struggle with them a little bit in the north, our cropping systems, planting technology, probably not really set up for great use of pre-emergence, but I think that we're going to have to start thinking about it at some point. And for me, I love flame. It's great. I'm northern New South Wales. It's cheap, it's effective, but what's the cost long term? When you're missing out on rotations, have a think about the long-term cost, I think, into our systems. So this here is a put together last night. It's a quick and dirty a look at the different products, I suppose, and understanding where their strengths are. And that's all I would say is, when you're choosing Group B chemistry, have a good hard think about which product you're choosing and how it fits into your system. And if all else fails, you know, you can always, you know, ring and ask us. We're happy to share the information with you. So, yeah, that's about all I have.